you hear me?
Yes. Yes.
Great. So this talk is about Eve, which is a project born about, officially launched in 2012 after EuroPython in Florence, beautiful Florence. And back then I gave a talk about how to build REST APIs based on Flask, which is one of the many web frameworks that Python has available to you. And in that occasion I did a very long talk. It was probably it was a workshop, not a talk, about Flask, about MongoDB, and why MongoDB was a good choice for building REST APIs. And at the end of that talk, I got a lot of feedback about my work and why don't you release it as an open source, because I would use it and stuff like that. And so basically what was a closed source project in company, we did into our company, was then released as open source, and so Eve was born. Let me see how this works. Okay. About me, real quick, the only thing that you should be concerned about is the last line here. I still love to code, despite my age, and all the rest is just the usual stuff. Doesn't really matter. So I'm still the creator and maintainer of this project, and in any case, it is powered by a few giants. One is, of course, Flask. How many of you know about Flask or use it? Oh, great! So I don't have to waste time talking about Flask, or not much anyway. Flask was the ideal choice for me, because I didn't need all the complexity and infrastructure that Django or other frameworks could bring to the table, because I just need a REST API. REST API is usually pretty simple in concept. You just have to send JSON back and forth with the client, and it seems simple, but it isn't really that simple. But from the point of view of the web framework, Flask is a very good solution, also because in my use case I needed to build actually a microservices network, and so Flask was perfect for that. MongoDB is the backend that is used by default by Eve. Actually, the community, in the meantime, since it's been released, has also added the new extensions for SQL Archive, for example, so you can actually use Eve with Postgres or MySQL or whatever you have. But MongoDB is the default database and data store used by Eve APIs. And Redis, which is used just for a few features, like for example rate limiting, that we will see later, which is, by the way, a great project. Do you use Redis or know about Redis at all? Great, great. So, very simple, quick start. This is all you need to launch your API. Basically, you import Eve, you build an application and run it. That's it. If you do this, right after you have installed Eve with pip install Eve, of course, you have to set up a settings PI, where in this case we are just telling Eve, hey, I have 2 endpoints, people and books, and that's it. It's a Python dictionary basically, and then you can run your API. Of course, if you go to the homepage of your API, what you get back is this kind of output. Here you have these links keyword, all the meta fields have this underscore before them. So here what you get is hypertext as the engine of application state, and this means basically that the clients can use the response from the API to navigate the API, to explore the API. Here we have an example. For example, here we have, hey, look, myself, you can find this is the link to me, and this is my parent with the URL to my parent, and I realize now that this example is broken, because here we need the people endpoint actually, since self is the people endpoint. This is what you get with copy and paste, of course, and here my parent is at this URL and the title is home. This title here is nice because eventually you can decide to have your clients could decide to update their GUI by using this information, it's meta information. Of course, you can disable this feature if you don't want it, you won't have this links section in your responses. And here you have the items, which is basically the documents which are available at this endpoint. Now we don't have any item here because we didn't connect any data store to our API. We just defined the endpoints. API is working anyway, but it isn't providing any data. We will do that in the next example. Here we see how we connect to Mongo. We go back to our settings file, and we just had a few Mongo settings, which are pretty standard Mongo stuff. You just give the username, password, port, and stuff like that. Now, I will try something that I shouldn't be trying, but I saw you guys deserved it, and so if it doesn't explode on myself, I will show you what I just told you. So this is a little launch script, run simple. As you see, it's very similar to the example the code we saw before. Let me go on the other side and just go with Python run simple.py. Now the API is running. Let me go back to Postman. Postman is a great utility if you want to test your API, prototype, see if it works, if it breaks, and everything like that. So here I'm going to grab my demo, home, and then I'm sending a request. Okay, so we went to the home page, localhost here, and we got back this. As you can see, the home page is telling us that we have some children actually. So we have a works and a people endpoint and their respective titles, as you see. Let's go to people. Here we have some data because this is connected to a data store actually, so we can see that the items collection is actually providing us some data. And Serena is my wife, by the way. And yeah, this is just a plain JSON, of course, coming straight from MongoDB. And as you can see, what you need to do in order to have your REST API online is very simple. You just pip install if, you create the application, and you run it. Of course, you have more than this at your disposal, but I just wanted to show you how easy it is to get started. If I go to the other endpoint, we see a different kind of data. Here we have some books, and so we have title, description, and also the last update date and stuff like that. And the links. So you see, every document has its own links section with a link with the reference to the individual document. So you can go up there, and if you type /567, you get to the single document, while here we are looking at the whole collection. Okay? Let's go back to the presentation. So, that was nice, probably very simple, but when you go online with a production API, and even if Mongo is schemaless, as you probably know already, what you really want when you go online is some kind of data validation. You want to make sure that the stuff coming into your database is validated against some kind of rule. What you do with Eve is just go back to the settings file, SA or whatever module you are using, and define a schema. So you say, look, the people collection has the documents in the people collection have a name field, an email field, a location field, and you define the type and some validation rules like max length, if it is unique or not. Email, you can use a regex. Don't use this in production because it is a very bad regex for the email validation. There is better. And the location, for example, is interesting because it has addition. It is actually a dictionary. So in MongoDB terms, it is a subdocument, and you can define a validation schema for the subdocument itself. For example, here you can see it here. And here is now the demo that we saw before is a read-only API. By default, your API is a read-only. This is for security reasons. But if you go to the settings file and change a resource method, you can say, for example, look, resource endpoint. So, for example, people or works are by default they accept the get method, but you can enable the post method. Method in a REST world is basically create or create a document. So by simply updating this list, you switch inserts on. And this is what happens with the item methods. So this individual document, you can say if the document can be read, can be updated, can be replaced, can be eventually deleted. So you have total control on every single endpoint. Here we are changing the configuration at the global level for all the endpoints and the API, but actually you can then go in at every single endpoint and change the configuration. So you can have one endpoint which is read only, another endpoint which is write only, and another one which is both read and write. And we will see that you can also go and change this based on the user or the client who is accessing your API. Here a few more configuration options like item title. You can set cache control for the endpoint when the cache expires. Configure an additional lookup. So you saw that the document has basically an ID as a URL. So for example /people/ID number. But you can also choose to, for example, use the field name as a lookup. So one can do /people/Nicola or Mike or whatever it is and get to the same document anyway. And what it is nice here is that you aren't doing any code. You are simply setting some writing in a text file basically. So let's see some features that you get for free by using Eve. First of all, you can query your endpoints and your database. For example, here we are in an example where we are using the where clause and looking for last name though. As you can see, this is basically JSON, but it is actually the MongoDB syntax. If you are used to MongoDB, how many of you use or know about Mongo? Great. So this is basically Mongo syntax. You simply, if you know Mongo syntax, doing queries on this kind of APIs, on Eve APIs is very simple, basically the same syntax. You can also use Python syntax. So for example, here is the same query using Python instead. You have sorting, so for example here we are sorting by the total field ascending, and I also have some a quick demo of this. Let's see. Here it is. So here we are. Let's go and see the params. Look, this is my request. So where location.city is San Francisco and sort by first name. I send my request, and what I get back, if actually we get to see this is a very small screen. Oh, here it is. So we are only getting documents, and you can see here, this is interesting, this is also Mongo feature, you can query at the subdocument level eventually. Here location is a subdocument of people, so we are getting documents who have location.city San Francisco. And we are also sorting in reverse order. Back to the presentation. Here we are, again, we can use Mongo syntax for sorting as well. So two different syntaxes depending on your users, basically, or clients, or whatever you want to allow them. Of course, you have pagination enabled already, so you can, your client can say, give me just 20 documents per page, or give me page 3, page 4, or whatever it is. In this case, we are getting max 20 results back per page, and we are asking for page 2 in a single request. We have projection as well. This is another MongoDB feature which I brought to the API level because I found it really interesting. What you can do here is say, okay, I want these documents, but I don't want, in this example, I don't want the avatar field because this is a picture, for example. I don't want my payload to be heavy. I don't care about the picture right now. Just give me the people profiles, but without the pictures. So you can do this with your clients or your customer or whatever it is. And this is another example of a projection where I just get the last name field back. So I can have a huge document with a number of fields, and right now, anyway, I just want the last names. I can do that with a simple projection, which in turn will perform a projection on the database. So you get an optimization of your bandwidth, both between the database and the API, and also from the API over the wire to your clients. Embedded resources, this is, I believe, very interesting. What we get here is, you know, in MongoDB you usually use subdocuments, and you can use, for example, you can have a list of subdocuments within the same document. So, for example, if you have an invoice, you can have an array, a list of subdocuments within the same document. But this is not always the case. There are situations in which you are going to have a reference to documents which are stored in other locations. Very much like you would do with the SQL, with SQL, for example. And in that case, there are situations where you are happy with just having a reference field to the other document in the other collection. But sometimes, especially when you are accessing your data from a REST API, you might want to get that document in the, which is being referenced by the main document. So what you get here is this. Let's see first. Let me go ahead. Here you see a simple document. So I ask for this document, I get the author, and since this is a reference to another collection, I just get the ID of the author document in the other collection. But if I say, okay, give me this document, but with embedded author, what I get back is the actual document from the other collection. So the API is performing your double lookup for you. So the client, and which is very nice in my opinion, is that the client does not have to perform two requests on your APIs to get both the informations. API is doing that for you toward the database, but the client does not need to do that. We get in just one lookup, he will get both the main document and the document which is on the other collection. So it's kind of like of a join, but it is performed at the application layer. Oh, let's see that in action. So here we have this request to the works endpoint, but please give me the owner as well. And here it is. I hope so, yes. If I manage to get down there. Here you see it. Where it is? Yeah, owner. And the data from the owner. If I just send a request for works, I only get the you see the ID of the owner on in the other collection. You can get both the JSON and the XML back from the API. Again, let's see that. You can disable this if you don't need to provide XML support. You see here that my request has an accept header with application XML, and when I ask for the same data source, I get the XML back. Of course, if I just change I'm not going to do that, but if I just change my header and I accept application JSON, I get JSON back from the same API and the same endpoint. This is an example of JSON. By the way, you can customize the name of this meta field from the API, so if you don't like updated, you want to use a different tag, you can do that. You just update your settings file with the name which you prefer. This is an application XML example. We already spoke about hypermedia as an engine or application state, so we are going to skip this. Parent, when you have a paging enabled, pagination enabled, you also get the links to the next page, for example, in this case. The API also supports versioning. So if you're interested in this feature, this is very nice. This was contributed, I'm very proud of this because this was contributed by SpaceX engineers. Do you know SpaceX, the guys who are sending Dragon ships to the International Space Station? And they needed this feature, and so they just implemented it and sent a pull request, which is very nice. So you can say, give me version 3 of the document, or give me all the versions of the same document, or just give me the diffs of the document as well. So it is very nice. There is also support for file storage, so you can upload files, pictures, giant files. If you want huge files as well, will be stored in GridFS by default, but you can actually, you do this by just adding a new field and saying that it is a media field. And this is all you need to do to get your support for uploading of files to your API. When you need to do an upload, here we are using curl, which is not very friendly for this kind of stuff, but you say here we are sending our pic as a JPG, and what you get back is a base64 string. Actually, you can change this kind of behavior. You can extend the field with a meta field. I'm not going into the details here, but you see you can get the content type, the profile, the size, stuff like that. And you can also choose to serve the file at a different point, which is very handy if you don't fancy providing the base64 string within your document, because you don't need that. It will be probably too cumbersome for your payload when you get the whole document back. You can get just an URL to the file, which will be served from a different point, and the client can go and fetch it when it needs to. You just have to set a few. Here you see you just enable this return media as URL. You set to true, and you say which is the media endpoint, and this is all you need to do to get your media endpoint ready. Rate limiting, this is powered by Redis, by my good friend Salvatore Sanfilippo. Here you see how you can, now what is rate limiting? It is a way to prevent clients to hog your API, to block your API because they are sending thousands of requests per second to the same endpoint, for example. You can set a limit on this. So you can say, this endpoint will just accept one request per minute window. So one request every 60 seconds, not more than this, per client, of course. So when you do this, the first request is accepted, and these headers are added to the response. So look, you have 0 requests left for this time span. If you send a second request within that window, you get a 429 too many requests answers. So you have to wait 1 second before you can do the request again. Conditional requests. These are nice, very important when you are in a RESTful world, because you want to allow clients to cache their content and send a request which is basically saying, hey, API, give me your document only if it has changed since my last request. I should have an example here. If modify since, this is, for example, a request which is give me the document only if it has changed since this date, and the document will be returned if it has changed, or you will get a 3 or 4 no content if the document didn't change. And the same you can do with e-tags. Every document served by the API have their own e-tag, and you can say, give me the document only if it has changed since this a-tag. And again, you get the document or the not modified 3 or 4 response back. I should actually have a demo of this for you guys. Let me see if it is. Yes, if not match. So here we are going to hit this document here, and we are going to say, just send me the document if it has changed since this e-tag, and you see that you don't get anything back in the body of the response, but you get a 3 or 4, the document has been not modified since then. So it is about optimizing traffic, of course. In this case, you don't get a download since you don't need it, because you already have your document on your client since you gave me its own e-tag, which was provided to you by the previous request, of course. There is also support for bulk inserts. You can insert one document, but you can also send multiple documents with a single request. This is again to optimize for performance, because if you have 10 invoices to be sent to the server, you might do 10 different requests, but you can also send an array of documents to the API in one go, and they will be stored. Let's see, not a bulk insert because it would require too much work, but we can just see one single insert I believe is interesting. Here we are creating a new person, so we have we are sending, you see here, content type JSON, so we are sending JSON, but we also have a body which is in fact JSON. So here is our new document. We are doing a post request, so the API has a post enabled for this endpoint. I'm just going to say store this document on the people collection. I believe that, yes. I hit send twice. The first time I didn't see that there was an actual answer here because it was below default. So the first time it got inserted. The second time we didn't see it actually. The second time I got an error, and the issue is that the last name is not unique, because I just inserted it before. So we see validation in place right now working, which is good. I had a demo for this later on, and we saw it here now. So, and you also get, here you get a hint of bulk insert support, because in the error message is there is one document contains errors, just because there can be multiple errors if you are sending multiple documents. In that case, you get an array of errors for each document which has an error. Here an example of a bulk insert request to documents and the response. One interesting thing here is that answers from create instructions and even for edit and replace operations are usually stripped down to the basics, just to the meta fields. So you get the document ID, the last updated time, the new e tag, and the links. You don't get the document back, the whole document back, because the assumption here is that you know about the document already. You just sent it over to me, so you don't need to have it back. But that's not always the case. And so you can switch coherence mode on, and in that case you will not only get the new meta fields, but you will also get the document back to you. So you can, this is basically needed in when you are using some kind of framework and ORM or stuff like that, and they also want the whole document back. But if you want to optimize for performance, again, for bandwidth, you don't need a document back usually, because you know about the data that you sold. What really changes is the e tag. You need the ID of the document, because you don't know that it has been created for you by Mongo, and I'm sending you back the new Mongo and the date of the operation and the status of the validation. Here we have a coherence mode on, and so you get back the whole document, as you can see. So there is also a feature that allows you to prevent overriding of documents with obsolete versions. This is basically done in a RESTful way. So if you send a request like this, this is an edit operation. So basically change this document here with change the first name for this document. But if you do this, a simple request, you get back a precondition required, because you didn't say which version of the document you have. You are saying that you want to edit this document. But do you know about this document at all? Do you have a recent version of this document which you want to update? If you have, then give me an e tag for this document. So here we have a second attempt where we are doing the same patch for the same change, but we are also telling, just update this document if it matches this e tag. So basically it's an attempt. Hey, I want to update this document, but let's only update the document if my version is the most recent version which you have on your data store. And so in this case, since the e tag is obsolete, what we get is a precondition failed. There is an e tag mismatch between your document which you have on the client and the document on the server. And finally, the third attempt is the right one, because here we are giving an e tag, and this e tag does match the e tag on the server. So basically, you are trying to update the most recent version of the document I have on the server, and so I will update it. This is all done to prevent clients with obsolete version of the document to overwrite or over-edit a document which has been updated by other clients in the meantime. So the client who gets who gets this kind of response should probably download the new version of the document and eventually edit the new version of the document if they want to stay in sync with the rest of the clients who are consuming the same resource. You can switch this feature off if you are not interested in concurrency control, of course. Data validation, we saw it already. In this case, 2 documents, one got inserted, but the first one was rejected because Clinton was not unique. There is also support for GeoJSON. If you are interested in this kind of stuff, you can do all kind of queries using MongoDB, again syntax, so you can ask for all the people who live in data in St. Petersburg or whatever it is. You get authentication and authorization by default. We will see a demo later on. Of course, the API runs all kind of Python, so 2, 3, and PyPy 3 actually. And there are a lot more features like CORS, cache control, uplog, soft deletes, which are also contributed by SpaceX, by the way, and is very nice. Logging, customized fields, support for JSON-P, multiple MongoDB instances, data aggregation. MongoDB has a very nice aggregation framework, and you can actually use it in your API. We don't have time to see everything. It's open source, so you can use even both commercial and open source and public domain scenarios. Now, what I want to stress here is that all of these features you get for free without any line of code. You don't have to code anything. What we saw is just setting, enable, if you don't have to switch anything off, you get all of these for free basically. Your API is online and that's all those features already working for you. You don't have to do anything besides connect the data store to the API. But there are some things that should be in the hands of the developer. For example, authentication. You want to implement your own logic to authenticate your user or your client, depending on your use case. So let's see what the framework offers to you as a developer. Custom data layers, for example. As I said before, Eve comes with MongoDB support, but you can just subclass the base data layer. Here we see an example of SQL Alchemy support. So here there is a new class which is SQL Alchemy, and we won't look at the code right now, but what it is important to know is that you just need to subclass the basic interface, basic class, and you can write your own data layer, access layer for REST APIs. I have a guy who is trying to do something for CouchDB, for example, and there is SQL already available. There is we will see later that there is an Elasticsearch extension, for example, which uses Elasticsearch with Eve and stuff like that. If you ever need to write some kind of data access layer, you can do that. Here it is the Elasticsearch example, for example, Elasticsearch data layer for Eve. And this is the Mongo. The Mongo itself is a subclass of the base data layer, which is available to you for whatever you need to do. The only difference is that this class comes down with pip install Eve. You get the Mongo class, but you could just replace it with your own implementation if you want to. Authentication. You have a lot of options here. You can say all the endpoints are authenticated by this kind of logic. You can split your authentication logic at an endpoint level, so you can have one endpoint which has some kind of weird authentication logic, another endpoint which follows, maybe another endpoint is using a different authentication API or a logic or whatever it is. You can have public endpoints and methods, and you can have private or authenticated endpoints. You can use role-based access control, so admins can use this endpoint in write access while users can only read from this endpoint and all this kind of stuff. And you can also have user-restricted resources, which basically means that what a user stores in that resource, he only sees those documents he stored there, and basically his own data is isolated from the other users. We are not going to see all of this, but I just want to show you how easy it is. You just import your basic auth class and you implement your own logic by doing this check auth method. You get a username, password that came down with the request, roles which are allowed for this endpoint, endpoint, etc. And for example, here we are just authenticating people who are admins and use the password secret. Not very smart, but it is just an example of how easy it is to do this kind of stuff. When you instantiate your application, you just pass your own authentication class to the API. So from now on, everyone sending a request with this basic authentication text will be accepted or not. Let's see this in action. It should be, I have to do. So let's switch from this script, to this one, which is a direct implementation of the example. You see here my basic auth, and I will only set the username and admins. So I'm launching this script here, and now back to our request. If I send a request, you see that I don't, that doesn't work. You see that I'm not allowed to access the endpoint anymore, because in this request I didn't provide, where it is, I didn't provide any authentication. In fact, you get a 401 unauthorized. Now, if I go and perform the same request, but I add an authorization header with, this is coded of course, but there is an admin and secret user. And we get our documents back, as you can see. So protecting your API is very customizable. You do whatever you want. In that class, if you needed to use some authentication scheme or an external API, for example, AWS or whatever it is, you can just do whatever you want with authentication. You have total control over it. You just have to return true or false once authentication check is performed by your authentication logic. And you can also extend the validation system. This is very common because EVE itself is based on Cerberus, which is an authentication, a validation library, which is also an open source project which you can use all by itself. It is also available as a pip install, and a lot of people are using Cerberus outside of EVE, of course, but you can use it to add custom data types, custom validation logic and normalization. Let's see, what this means is, for example, that you might have a data type like in MongoDB we have object IDs. Object ID is basically a string which is a very long sequence of numbers and letters, but you want to make sure that the field coming in is an actual object value, valid object ID value. So it is not an integer, it is not a string, it is an object ID, it is not a Python basic data type. You can extend the validation system and say, hey, this field is an object ID, and you provide your own authentication and verification logic for that field. And the same happens for custom validation, or sometimes you want this field is only valid if this other field has this value or something like that. You can do whatever you want with the authentication logic, validation logic, sorry. It's pretty powerful already, but you can extend on it and build your own logic. Event-hooks is also very nice. You can plug custom action into your API loop. I have an example here for this. Maybe I have also, no? Yes, you can you have event hooks everywhere, basically. Every kind of method performed by the clients or performed by the API has its own callback system to which you can hook up your callbacks functions and customize responses and however you want. For example, here we have a different script, this one. So we are defining a function, a callback function. We receive the endpoint and the response that the API is going to send to the client. Here we are looping the documents in the API and adding a new field to every single document in the response. Then we launch our API. The only thing that we do is attaching this callback function to the onFetched event. So every time an endpoint, a resource is going to be has been read from the database and is going to be sent to the client, your callback is being invoked for you and executed. So if we launch this version of the launch script, so this is called the hooks. Okay, let's go back to Postman and perform a people request. Okay. You see that every single document in your response is now customized, and in this case we added this field with this value. I hope you appreciate my effort here. And but the concept here is that you can dynamically update your documents live. As the API is serving a request, you can basically do whatever you want here. For example, on Stack Overflow, somebody asked, I don't really need all these meta fields. How do I remove that? You simply remove them. You attach your own callback function. You delete the field that you don't need. You send them over to the while. Okay, back to the slideshow. Here you have an example, which I, as you can see, this was done at FOSDEM in Brussels a while ago, a couple of years ago, but it's basically the same example. And another nice thing, what I really like about Eve, the reason because why Eve is born basically, is that Eve is in fact a Flask subclass. I'm just a subclass in Flask. So if you know Flask, whatever you can do with Flask, you can do with Eve. And this is very powerful because, for example, you can do stuff like this. Let's go back to the last script in this demo, which is this one. Here we have, as usual, importing Eve, create an Eve app. If you are used to Flask, you know that usually you do app equal Flask. As you can see, the syntax is exactly the same. And here we are adding a custom route to the hello endpoint, and this endpoint is bound to return an hello world message. And then we launch our API. This is very similar to the Flask quick start page, if you ever seen that. It's basically just plain Flask. But what happens here is that we are adding this endpoint to the API that we configured in our settings file. So the result here is that if we launch this, so the name is hello, okay, let's go back. If we go to the people endpoint, it works. If we go to works endpoint, it works. I hope so. Yes, it does. But I can also go to the hello endpoint, and it also works. So you can mix and match your API with regular Flask. You can do whatever you want. You can do your own custom endpoint servicing, whatever you want. Now, I don't usually advise you to do something like this. You probably want to split your API in different services, different APIs or microservices. Every service being very specialized in something. So if you are serving data from one API, you are serving probably other stuff, static HTML, whatever you want, from a different URL, but you don't have to. For example, there is a guy who contributed an extension to Eve which is called EveDocs, and all it does, it is very nice actually. What it does, it provides a docs endpoint, and if you point to that, if you go to that endpoint, you get API documentation, We had a talk yesterday about Swagger and description languages and stuff like that, about two guys who are there, and a very nice talk, by the way. And what you get is documentation for your API for free, because what it does is read the settings file, see all the documents, how they are, what are the fields in every document, what type of data these fields are, and provide documentation for the user. And what it does is simply using Flask blueprints. It just adds a new blueprint to Flask. For you guys who know Flask, you know what I'm talking about. They just add a new blueprint. You can add blueprints to Eve as well, with all the functionality you want to add to this engine. So this is the sample we just saw. I just added a slightly different sample here. We are using this endpoint, but we are also using if features. We are saying this endpoint also requires authentication for the resource endpoint. So this is kind of a mix between Flask and Eve. This endpoint now, with this decorator, is going to be available to the clients, but only if they provide their username and password from the authentication logic which we enable for the rest of the endpoints on our API. So you can protect your custom endpoints with the same authentication logic which you have been using for API endpoints, RESTful API endpoints. And of course, as a developer, you can also build your own custom file storage engine. So for example, as we saw, Eve uses GridFS, but maybe you want to store your pictures on S3, Amazon S3 for example, or maybe you want to store your files in a folder on your local disk or somewhere. Whatever you want to do, you can do, because you can extend it. I don't remember if I have, no, I don't have an example here, but basically, again, it's just subclassing the base media class and overload some method, and you can do whatever you want. In fact, there is a guy who did an S3 extension for Eve. So, as you can see, as a developer, you can customize your API in many ways. Now, this project has been, as I said, it's been launched in 2012. It's been around for some time already, and there is a nice community around it. We have about 100 contributors to the project right now. It's been installed everywhere in the world. There are very nice companies using it, as I mentioned already. And another company using it is Dailymotion. I don't know if you know them. They are a video streaming company like YouTube. Actually, they claim to be the second largest streaming website on the internet, but I suspect that everybody does that, claims that. Anyway, the community contributed a lot of extensions. For example, Swagger, which basically allows you to provide the Swagger documentation for your API. This is actually a contribution by the creator of the Eve project, which is me. So this is my own toy project, and it's still in early stages, but it already works. So what you get here is this. If you have, I'm sorry for the quality of the image, but if you use Eve Swagger, which again is just a Flask blueprint which gets attached to your API, you get this kind of stuff, all the Swagger tooling at your disposal. So here we see that you get a JSON with all the documentation, and also a website with all the data about your API. This is Swagger documentation built on top of the demo we saw earlier, for example. There is an Eve SQL Alchemy extension, Eve Elastic for Elasticsearch, Eve Mongo Engine. If you are used to Mongo Engine, you can connect your Mongo Engine classes to Eve. There is a C# client, async C# client for .NET application. This is again provided by yours truly, because I actually come from the C# world, and we are using, the one reason why Eve exists is that I needed to write iOS, Android, WinPhone, Windows desktop, Linux applications, and I needed to keep them in sync, so I needed a RESTful API, but the code I write for mobile application is C#, so I had to write a div.NET client. You can use it if you are into that kind of stuff. Dailymotion provided this super nice extension which allows you to use OAuth 2.0 with Eve, and this is another Flask extension which allows you to use authentication, and this is what I'm actually using. So right now we have a token support authentication for Eve. You hit an endpoint with your username, it gives you back the token. You use this token to authenticate to the all the microservices we have available, and the token has, of course, it will at some point become invalid. You will have to get another token, and this Flask Sentinel allows you to do this with MongoDB as a backstore as well. You can look it up on my GitHub. These are some of the contributors. You are welcome to join us. You can work again as the talk before we just listened to. Here we are looking for people writing documentation, fixing bugs, adding code. Contributors are welcome. I strongly invite you to give a look at our GitHub repo and send your own pull request or whatever you want to do. You are welcome to join the project. This is the URL to the project itself. Here you find the documentation and all the links that you need to, and here is my Twitter handle, my website, my email. If you want to get in touch, don't hesitate to ask me anything. I will try to get back to you as bad as possible. And thank you.
Thanks. A lot of questions. Okay.
Well, first of all, thank you for your great speech.
Thank you.
It was enjoyable, and I like Eve. I like how the idea and how it looks like, how it feels, probably. But it's not that clear for me what are the good use cases and the bad use cases to take Eve. You see, I want to use Eve, but as I can see right now, the good use cases probably are when I want to build fastly some backend, say in Hackathon or something like that, or to build simple microservice. And the bad use cases, in my current opinion, is probably when my backend is not microservice, or when my microservice use cases are not such trivial, and when they are sort of unusual. So this is my current opinion. Is it a right guess, or could you please
kind of, yeah. In some way, yes, you are right, because the main goal of an Eve Power API is serving as a front end for some data which we have stored somewhere. So if you just need to expose data on the web in a RESTful way, probably Eve is a good option for you. Either you're using a Mongo or using SQL, that's not the matter at hand here. But since you have the full Flask at your disposal, you actually can do whatever you want with Eve. It doesn't prevent you to building custom logic, advanced usages. For example, the guys who did the versioning, that particular feature, and yeah, it still deals with data if you want. It's still about data, but you can do with Flask whatever you want. Dailymotion uses it for streaming to their mobile. Don't ask me how they use it, but I know they use it for streaming content to their mobile devices, for example, so on iOS and Android. So yes, basic use is data front end, but since you're using the whole Flask framework and you can do whatever you want with it, and so it's not only limited to that kind of scenario. A lot of people are using it for prototyping, to be honest. They go online with Eve. They have like in 5 minutes they have an API ready, they can start working on the clients, for example, because they already have an API working, and maybe they will replace Eve with a custom implementation, and at some point. But the nice thing is that they go online quickly with an API and start working on all the rest of the infrastructure. But a lot of people are using it in production actually, and the reason I suspect is, one, you go online really fast. Second, you adapt and change really fast, because if your document changes, you just go to the settings file and then you fill the data validation rule that you are done, relaunch your application, and you are good with it. And if you are starting, and you will sooner or later, starting to add new components to your API infrastructure, call them microservices or not, or giant monolithic applications which talk to each other, it is very useful to have a common surface API in all of these, because otherwise you end up with a team as this API was written by team A, this by team B, and they have different specifications, they work in different manners, so you have to ask to that guy who did that API to update that. Instead, if you have a standard specification for your services, that's going to be really useful.
First of all, thank you for your great presentation.
Thank you.
And I have two questions actually. First one is, when you mentioned about filtering requests,
Yes.
Is there a possibility to add my own syntax for that?
So you say not, I don't want,
I don't want to use, for instance, syntax like Mongo. I want to use something like SQL request.
Yes, you could actually do that, because it is again, this is also a field where you can go and customize if you want to.
Mm-hmm.
It's not as easy as customizing authentication logic or data validation logic, but you can do that. Actually, there is a guy who has a fork where he did that, so I can eventually check it out and let you know how he performed that. It's just about subclassing the filters class and doing the stuff you want to do, so it shouldn't be a big deal, really. It's just that unless you send a pull request and we merge it, and so we make it available to everybody, it's just your stuff, and then you have to work on a fork basically, which is going to be kind of not really nice if you want to keep downloading and using updates coming from the main repo, of course. That's the issue with every fork basically, but
yeah.
You could do that.
Indeed. And the second question, is it possible to use simultaneously several backends, data backends?
Yes, if you're using Mongo, you can actually configure your endpoints to be served by different Mongo instances. There are two kind of aspects here. You can have different Mongo databases served by different endpoints, but you can also have a different Mongo for every different user, which is very interesting in my opinion. This is actually what I'm doing right now. So when user A goes to the people endpoint, he gets data from his own database. He doesn't know, of course, but I'm using different database for every user, which allows me to guarantee perfect data isolation between users. Yeah. And if the users want to move to its own custom deployment on its own private network, he can do that. He can just install even locally and MongoDB locally, and he's good. I just give him the database. He pays me, and he gets the database, and he goes locally. That's one option. You can, of course, use one giant database for every user, and there is a specific resource feature which is called user restricted access, where, as I mentioned before, you have one people collection for everybody, but every document stored has its own user ID, and so which is transparent to the user. So when the user goes to that endpoint, he only gets his own documents, but at the data level, that collection has documents by all users, which is kind of a nightmare if at some point he says, hey, I want my data back, because you have to actually pull his own data and store them in a copy in a database just for him. That's why I'm using isolated database. But you can do that. You have different options.
Yeah, thank you.
You're welcome.
Yeah, thank you very much. Unfortunately, we're a little bit out of time.